Hey everybody, let's give this problem a try. So we're using the method of sections, and this particular problem is asking about these three members, CE, CF, DF. So we want to cut through those members for sure, and then it's up to you. You want to pick this section over here, or do you want to cut through these three members and pick this section over here? There's no real right or wrong answer either way. So the left section, the free body diagram will look something like, okay, so then there's a pin at A. So if I pick coordinates, let's say like this, then I can decompose the reaction at pin A. So I'll decompose it into X and Y components. Okay, and then there are these two loads, 200 kilonewton, 200 kilonewton. And then there's member DF. So I'm just going to draw that axial force in tension. I don't know if it is in tension or compression. So if I draw it in tension, and if my answer is positive, then I was right, it's tension. If I draw it in tension and the answer is negative, that means the axial force is in compression. Okay, then joint C is over here, so then there's member CF, so CF in tension, and then that's at a little bit of an angle, CE. Okay, there we go. But then if I pick the right section, then that will look, let's see, kind of like, not exactly, but kind of like this, where there's a roller at I. There's a roller at I. There's these three loads, 200 kilonewtons each. And then there's member DF over here, member CF over here, and then member CE over here. Okay, so which section do you want to pick? Totally up to you. I don't see any one or the other being better, so but I already see an issue is the left section. I have 1, 2, 3, 4, 5, 6, 7 forces. The right section I have 7 forces, but then I have 5 unknowns here, 4 unknowns here. No matter which section I pick, I have 4 or 5 unknowns. But then at most, I can write 3 equations. So I can't get away with solving this with only those 3 equations. I'm going to have to do something else. That something else is I can draw the free body diagram of the entire structure. Right, so the entire structure, whatever it looks like, not exactly, but it's kind of like this. And then there are the 1, 2, 3, 4, 5 loads, 200 kilonewtons each. And then there's that pin at A, which I'll decompose into X and Y components. And then there's the roller at I. Okay, so now for the whole thing, the free body diagram of the whole structure, now I have 3 unknowns, and I can write 3 equations. So for this free body diagram, I can already solve for the reactions at the supports. And once I know those 3, if you take a look, I will know these 3 unknowns. So that means for this section, I'll only have 3 remaining unknowns. For the right section, I will only have 3 remaining unknowns. So then it totally doesn't matter which one you pick, which then, if that's the case, I mean, just personal preference. I think there's less to deal with because there are just the 2 loads over here versus 3 over here. Totally doesn't matter. Either way, we got to do this first. Okay, so let's solve for this first. Okay, so for this whole thing, actually I need the numbers. Okay, so I will write over here. Okay, some forces, actually, hold on. I'm going to move this over so then I can write. Over here. Okay, so some forces in the x direction. We're using this free body diagram, right? So I got AX. Oh, okay, so that was easy. Equals 0. Some forces in the y direction. AY, I, and these 5. AY plus I plus 5, oh, not plus, minus 5 of those. So 1,000 kilonewtons. And I think I got everything. Equals 0. All right, let's sum torque about anywhere you want. Where's good? Here, 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 here. It doesn't matter. But maybe let's be clever about it. If we sum torque about here, then there would be no torque about this point from AX or AY or this one force. There's going to be torque from all these other 5, but at least we got rid of 2 unknowns from that equation. So I'm going to sum torque about point A. Okay, and then if X is here, Y is here, Z is towards you, right out of the page, which is this way. This way is Z. So counterclockwise for this coordinate system would be positive. Okay, so counterclockwise is positive. So I got about point A from this force is, however far this is, times I. How far is that? 5, 10, 20 meters. 20 meters times I going counterclockwise, which is in the positive Z direction. Okay, there's no torque due to this force about this point because it's aligned like this, right? There's torque from this one, and then the lever arm is this far, right? 5 meters, and would be going clockwise. So minus 5 meters, 5 meters times 200 kilonewtons. So that's from this one. And then from this one, that's here, right? This lever arm is 10 meters. So minus 10 meters times this force, which is 200 kilonewtons. And then now for this force, the lever arm is here, which is 15 meters minus 15 meters times 200 kilonewtons, and then this one, which is 20 meters times 200 kilonewtons equals 0. Okay, so we got 3 equations. Let's keep track of our unknowns. This, 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 this. Okay, so for this, well, right here, AX is 0. That was easy. If you notice, this equation only has 1 unknown, so solve that for I. Once you get that number, plug it in here, solve for AY. Okay, let me pause the recording, and then I'm going to punch this in the calculator. Actually, before I punch in the calculator, I can do a little bit of simplification, right? So for this, I can factor, okay, so I got 20I, and then all of this can go on the other side of the equation, and then I can factor out 200 kilonewtons. And then what's left is 5, 10, 15, 20. 5, 10, 15, 20. Right, and then just this goes in the denominator here. Okay, and, well, this is 30, 40, 50, right, so that's 50. So right in this cross here. And then 200 over 2 is, 200 over 20 is 10. So 500. And then that goes here. Right, so then AY is 1000 minus 500. Okay, so AY is 500 and I is 500. I guess we didn't need a calculator after all. Okay, so I is 500 kilonewtons. AY is 500 kilonewtons. They're kind of messy. AX is 0. Okay, so I got the 3 reactions. So if we go back to this, AX is actually 0. Here, AX is 0. AY is actually 500 kilonewtons. And I is 500 kilonewtons. Okay, so I'm just going to erase AX equals 0 over here because we know it's 0. Okay, so now looking at these two sections, I think I'm going to pick this one just because there are less forces to deal with. Okay, I'm just going to copy it and move it over. Okay, so now we have this free body diagram. Okay, so for these, so some forces in the x direction, we got, oh, actually, these are at some angles. Well, CF and CE are at some angles. So let's say CF, I'll just call it maybe theta, what should I call it, F? And then CE as at some angle, I'll call it theta E. Okay, so I need to know some of the geometry, which let's look at the picture again. Okay, so if you look at, let me erase some of this. Okay, let's focus on this triangle right here. See this triangle right here? Here. Okay, so the base is 5 and the height is 7 minus 3 is 4. Okay, so the base is 5 and the height is 4 for CF. What did I just say? The base is 5 and the height is 4. Okay, so theta F has got to be arctangent of opposite over adjacent. Okay, so we know that angle. Now, the other angle. Let's look at this triangle right here. Okay, so the base is also 5, and then the height is 4 minus 3 is 1. Okay, so this one, the base is 5 and the height is 1, which means the angle is arctangent of opposite over adjacent. Okay, so we got the two angles. So, that's E. Okay, so we got those two angles. So they're known. Okay, so, and then in this picture, the angles are with respect to horizontal, the way I kind of drew it. So kind of TCF, meaning like this is theta F. And then the other force over here, TCE. This angle right here is theta E with respect to horizontal. Okay, so now in the x direction, we got TDF plus TCF cosine of theta F, which we know, plus TCE cosine theta E, which we know that angle. What else? That's it, equals 0. Okay, some forces in the y direction. We got those two going down, minus 400. this one going up, plus 500k, and then that's horizontal, so just the y components of these two, plus TCF sine theta f plus TCE sine theta e equals 0. All right, now let's sum torque about anywhere we want. I think it would be clever if we picked right here. If we sum torque about this point right here, because there would be no torque due to either of these two, which are unknowns, and then also this one. So we'd get rid of two unknowns. So I think that would be clever. So what point is that called? That is at joint E. Okay, so about E. About E. So there's no torque from either of these two or this one. So that's nice. There's torque from this force, and that's going to be going clockwise, which is negative. So negative, and I need to know how tall that is. Okay, so that height is, looks like that's over here is over here, which is 7 minus 3, 4. 4 meters and TDF. And then there's torque from this. And these two are actually in line, right? So it's this minus this at this lever arm right here, which that lever arm is 5 meters. So plus 5 meters times this minus this, 500k minus 200k, so 300k. Okay, what else? Is that, I think we got everything. This one, this one, this one, that's it. Equals 0. Okay, so then we got, this is unknown, unknown, unknown. Okay, so there we go. So if you look at, let's just label them. Equation 3 has one unknown. Solve for that first. Take that value and then plug it in here. And then we're left with 2 equations, 2 unknowns, right? So just do substitution, solve for one, plug it into the other, and then you have both. All right, I can leave that computation to you, or I can pause and do some of it. Hold on. Oh, let me make some space here. Okay, I'll just do a little bit of work. You can always stop the video here. I'll just do a little computation, right? So for this one, for example, just this can go on that side of the equation. So then TDF would be 5 meters times 300 kilonewtons over 4 meters. Right, so punch that in the calculator. This would be, just 5 times 300 divided by 4 kilonewtons, if you just punch these numbers. Okay, and then take this value and plug it in here. And then now, if you look, equation 1 would only have 2 unknowns, and equation 2 would have 2 unknowns. So you'd have to solve one, just pick one. So for example, from equation 2, for example, let's say you want to solve for whichever one, TCE. TCE sine theta e equals, move all this on the other side of the equation, negative TCF sine theta f. Okay, this is actually 100k, which goes on that side, becomes negative 100k over, I'll move this over here, sine theta e. Okay, so there's TCE. Now take this and plug it into equation 1 here. Right, so plug into equation 1. TDF, which you know the answer from right here, plus TCF, we're right here now, right? Cosine theta f plus TCE, which is this. Oops. I'm just going to copy it and paste it. This is TCE. We're right here. We're right here. TCE cosine theta E equals 0. Now if you look at this, there's only one unknown, right? So then just finish this algebra, right? Move this on that side, factor out TCF, and then you're done. Okay, hope that's helpful. Or if you have questions about the algebra, just let me know. Other than that, I'll see you on the next video.